Okay, guys, well, hello, welcome back. This will be the last of our crazy hodgepodge radical unit. So it is going to be rational exponents. And you want to think of that as an exponent. That is a fraction. Okay, so let's say we had x was our base, and it was raised to the m over n, right? So it's a fractional exponent, right? Well, what that actually equals is the square root of x, all right? And then what I think of is that whatever's on the bottom here, that's whatever root it's going to be raised to. And then I like to think of it as being in parentheses, and whatever the numerator is, that's actually the exponent it's raised to. So if we want to think about it like this, that the numerator becomes the exponent, and that the denominator I just butchered the spelling on that one, becomes the index number, right? What root are we taking? The square root, the cube root, the third, the fourth root, fifth root. Okay, so that's kind of how we think about it. Let's actually do some examples from a root to a rational exponent. And then hopefully this will bring clarity to what all of this looks like, because it looks super confusing, huh? So root to rational exponent. Okay, this is how I like to write it. Let's say that I have 5 rad x raised to the second power. Well, remember, whatever's in the radical, that's actually your base number. All right, and then right here, this 2, the 2 is always your numerator, and whatever index number it is, so in this case 5, that becomes your denominator. All right, so without colors, if it looks a little bit easier to you, that would be x to the 2/5 power. All right, that's when we're taking it from a root to an exponent. Let me just fold my paper here so I can get a little balanced, just so I don't write all over the place here. All right, so let's give it another shot. Let's say that we have 2, our next example, and it is 4. The index is 4 to the AB. Well, we know that this AB here is going to be our base, so we can put it in parentheses, AB, and we know that this right here, our index, is going to be our denominator, right? So this would be raised to the 4. The exponent, well, we weren't given an exponent, but what does it mean when there is no exponent? What exponent are we actually raising it to? When there is no exponent, we're actually raising it to the first, right? So AB to the 1/4 is how you would convert it back into a rational number. Okay, now this one, number 3. Let's say we have x, all right, the square root of x. Okay, this is super, super important. So the square root of x. Well, whenever you aren't given a number right here, you just need to assume that it's 2. So we are going to x on the bottom, right? And remember that our index number always becomes our denominator. So right here, 2. And then also remember, if there was no exponent, it's simply raised to the 1/2 or to the 1. So the square root of x is actually x to the 1/2. And let's rewrite that. And I want to highlight that because that's super important. So the square root of x is equal to x to the 1/2. That's super duper important because you guys will use that a lot in Algebra 2 trig and pre-calc and stuff. So this is important information right here. Okay, so that's from a root to a rational exponent. Well, what about if we have a rational exponent and we want to change it into a root? Because that is actually the easier way of solving them. So we'll start with example number 4 here. Well, actually, let me write that title so you know what we're doing. A rational exponent to a root. Rational exponent to a root. So number 4, let me get some white out so I can erase that other number 4 that I did. And we're going to have x to the 4/5. And we're going to think of that. We're just going to go ahead and write the x inside. And we're going to try to remember, oh, okay, the denominator always stood for the index numbers. So 5, and we're going to put a 5 out here. And the numerator, this 4, always stood for what we were raising it to, so to the 4th. So we have, when it's x to the 4/5, we technically know it's the 5th root of x raised to the 4th power. And what would that would look like without all this color? Just so maybe you have more of a black and white mind, is x to the 4th. Oh, and I would just put my parentheses around here. I like to put parentheses just because it makes it easier when you're solving it a little bit later. So let's try another one. Let's go ahead and do 16 to the 3/2. So what I always do is I go ahead and I write my radical and I take that base number and I put it inside. And then I look, okay, here's my denominator. So that's what it's going to be raised to, the 16th. And then I'm actually going to look here and see that I'm going to cube it. Well, now the difference between this problem and the problems up here and this one is that we can actually solve this. What is the square root of 16? Well, the square root of 16 is 4. And then remember, we had to raise that to the 3rd power. So 4 to the 3rd power is, why did I write 16? It's 64. Oh my goodness. Is 64. So 16 to the 3/2 power is technically 64. I find it much easier to write it as a radical and solve it that way. All right, let's try it again. Let's go ahead and do number 6. And we will do 81 to the 1/2. All right, I'm going to start with my 81 under the radical again. I'm going to put my parentheses around this. And I'm going to see that I'm raising it. It's going to be the square root, right? And I'm raising it to the 1st power. Well, if we take the square root of 81, that's simply 9. And 9 to the 1st power is 9. So we would know our answer is 9. Okay, I want you guys to maybe try this one if you're feeling pretty good. So let's say we have 27. And it is 2 raised to the 2 over 3. So you guys go ahead and see if you can write it out, just how we've been talking about, okay? So pause me for a second and see if you can write it out. Okay, if you need guidance, totally fine. So remember, this goes inside the radical. This is our radicand. Our denominator right here is always what root we're taking, so the third root. And this number right here is always going to be our exponent, right? What we're raising it to. So we are going to take the cube root of 27. And if you can't remember your cube roots, just go ahead and grab that sheet that we did a couple notes back. And that has your cube roots on it. So the cube root of 27 is 3. And we have to raise it to the second power, right? So we would get 9. That would be our answer. Okay, let's go ahead and move on to simplifying roots with variables. So I'm going to move this up just a little bit here. I'm running out of room on my desk. And simplifying roots with variables. Again, this is, whoa, a really crooked line. This is just all over the place kind of stuff. Okay, so let's say, but it is all very important. Oh, let me circle my numbers so we can tell them apart. Let's say we have 36 x to the 4th. And remember, because there's no indicator here, that's the square root. Well, what I like to do is I like to break these apart. So I like to think of it as the square root of 36 times x to the 4th. Right, now if you guys remember, the square root of 36 is simply 6 and 6, which is a pair. So that would get to come out of the radical, right? So over here, I'm going to go ahead and write a 6. And then I'm going to take the square root of 4, or x to the 4th. What you can think of it as is you can think of it as whatever this is divided by the root. So we're going to do 4 divided by 2, which is actually equal to 2. So that means we would factor out an x squared, all right? So that means that I would then have times x squared, and my answer would be 6x squared. The best tip for me to tell you would be to, in order to find out what is here, divide the exponent on a variable by the index number. So this is the variable, right? And it's to the 4th. We divided it by that index number. Remember, this is 2, and this is where we got the 2 from. So divide the exponent on a variable by the index number. Okay, so I'm going to go ahead and turn the page because I'm running out of room here. But I also want to show you another way that you can do these. So if you're a little stumped there, what you can do is I have an or here. Or you could go ahead and take that same problem. You can do 36x to the 4th. All right. And again, I would break it apart. So rad 36 times rad x to the 4th. And again, you could look for pairs, right? Because they'd be in pairs since it's square roots. So 6 and 6, you would know that that could come out. So we'd have a 6 here. All right, and then you would see the x to the 4th. Oh, that's just the same as x times x times x. And I have a pair here and a pair here. And that would simply be x squared. So my answer would still be 6x squared. It's just depending on what you like to do. I like to divide just because it becomes a little bit easier. But if you're more comfortable about expanding it out, that's totally fine with me. Okay, let's try another one. Let's do number 9. Let's say we have the square root, because there's no number there, of 8x to the 7th. So again, I'm going to write that in separate things, broken apart, the square root of 8 and the square root of x to the 7th. Okay, well, I'm going to break apart 8. The biggest perfect square that can go into it would be 4. And then there's that 2 left over. So what I'm going to do is I'm just going to take the square root of 4, which is 2. Yes, which is 2. And I'm going to just hold off on that 2 just for a minute. Okay, and then I'm going to think, oh gosh, I'm going to take that number, 7, and I'm going to divide it by the index number, which is 2. Well, 7 divided by 2 is 3 with a remainder of 1, which means that I would have x to the 3rd with 1 x left inside. So I would simply be this 2 that was left over when I factored 8 would stay inside, and this 1x would also stay inside. So to give you some clarification on that, whatever the remainder is, the number of that x stays inside of the root. So the number of x's that stay inside the root. And this right here is the number of x's that can come out of the root. Okay, so let's try it again. Let's do example number 10. And I just keep forgetting to circle them all, don't I? Those were terrible circles. Okay, I'm going to take the square root of 45 and have x to the 5th. So that would be rad 45 times x to the 5th. Well, when I break 45 apart, the biggest perfect square that can go into it would be 9 and 5. The square root of 9 is 3, and the 5 would be left over. I'm just writing them below now. It's probably going to be a little bit easier to follow. And then I think, okay, there's my 5. So I'm taking this 5, and I'm dividing it by the 2 that's left, that it's the index of what it is. So 5 divided by 2 is simply 2 with the remainder of 1. So that would be x squared to represent this 2 with 1x left inside to represent that x. And I would simply multiply those 2 together, and I would end up with 3x squared rad 5x would be my number, which seems like a lot. It does seem like a lot, but just break it down and go step by step, and you guys will be just fine. Okay, let's try number 11 over here. And we will do the square root of 27 x to the 9th, y to the 2nd. So we're going to take the square root of 27 times x to the 9th and y squared. And remember, all of these are raised to the 2nd power. So we want to think of the biggest perfect square that can go into 27, and that would be 9 and 3. The square root of 9 is 3, and this 3 can't go any further, so it stays by itself. So the square root comes out, square root of 9 is 3. What's left over stays in there. then we're going to think, okay, there's our exponent 9. We're going to divide it by 2 because 2 is what type of square we're taking. 9 divided by 2 is 4 with a remainder of 1. That means we would have x to the 4th with 1x left inside. And then lastly, we would have 2 divided by 2, which would simply give us 1. And that means just 1y would come outside. So we would combine all those together. We would have 3x to the 4th y radical 3x. Okay, so let's try our very last one. And this time, we're going to cube it. So it is going to be a cube root this time, which is going to be 32 x to the 4th, y to the 9th, w, which looks super intimidating, but break it apart. So we're going to do 3 rad 32 times root 3 x to the 4th times root 3 y to the 9th times root 3 w to the 1st. Okay, so we want to, this time, since we're thinking cube roots, we want to think of the biggest perfect cube that goes into 32. So if you need your list of perfect cubes out, that's totally fine. The biggest perfect cube that can go into it would be 8. 8 times 4. And remember, these are all cube roots, so don't just start thinking square roots. They're all cube roots. Okay, so the cube root of 8 would be 2. And 4 can't be simplified any further, right? There's no cubes. So it would be just 2 cube root 4. All right, and then we're going to look here, and we can still divide. We're still going to do 4 divided by 3, which should be 1, remainder 1. So we are going to have x cube root x, because we were able to pull 1x out, and then that 1x that was left over. And now we're going to do 9 divided by 3, and that's going to give us 3, and there's nothing left over, so it's simply going to just be y to the 3rd. In case you're wondering where I'm getting these, remember, I'm dividing by 3, I'm dividing by 3, and again, I will divide by 3. This is only raised to the 1st, right? 1 divided by 3 you can't do. It would be 0 with a remainder of 1, right? Which we can't really do, so the w would just stay as it is. And then you would combine your problems. So 2x y to the 3rd. Whoops, the w had to stay in to the 3rd root. Oh, not, yes, y to the 3rd. And then cube root 4x w. And that would be your answer. It seems like a lot, I know. Just break it down and go slow. Whenever I'm doing these just on my own, I still break them apart, even to this day. So just break them down and go slow. And that is it for this video, and that wraps up the hodgepodge of exponents. Again, please come to office hours Tuesdays from 12:30 to 1:30. Reach out if you need additional support. And I miss you guys. Hope you're doing well. Bye.